Well, thanks, Paul.
Okay, thanks, Daryl. So we're going to talk about Network Monitor 3.4. It's a protocol analyzer. How many are familiar with Network Monitor? Yeah, our PMs are good. Okay, how many people use Wireshark? All right, quite a few. So you can see some similarities here. So first of all, my name's Paul Long. Like Daryl said, I'm a senior PM on the protocol engineering team. I write a blog, so you're happy to visit. A lot of stuff I discussed today is mentioned on the blog. Previously, I worked in CPR, which basically was a critical problem resolution team. So I worked with networking traces a lot, and so I have a lot of experience here. And finally, on kind of a personal note, I'm interested in recording and playing music. So I built a studio in my two-car garage, which my wife now hates me for. So key takeaways. Want you guys to understand how to use the tool, to get the most out of it. One of the major advantages is that it parses everything, all Microsoft protocols, very well. That's its major strength. So be a useful tool for you guys to understand how to use. I'll say Windows protocols. It does other protocols as well, but Windows protocols, it does almost everything. How to find interoperability problems without reading the docs, kind of maybe a useful thing for you guys to understand interoperability issues with your products. And then finally, another key takeaway is how to learn how to document issues and annotate captures so that if you send them to us, we can use that information to tell what's going on, or if you share traces with other folks, it's a good feature to learn how to use. So quick background. Basically, the idea here is we had a tool a long time ago, in fact, how many people have used Netmon 2.x, the 2.0 product? Anybody? Well, it was a long time ago. We stopped using it for a while, or stopped updating it for a while, and then we finally started working on 3.0 and have since put out a bunch of revisions. So we had a new vision, new team, new design. So basically, we had these new ideas that we wanted to put forth in this new product. We had some high-level goals. We basically want to make all these things easy to do, straightforward. Safer is interesting, since the parsers, and Wireshark parsers are DLLs, right? And so there's some security issues there. What we did is sandbox them with our own language so that they, one, were protected. You didn't have to worry about, installing a DLL on your server that's doing a capture. But that also means that these things are editable, and they're part of the product itself. So you can go in and look at the code, the MPL we call it. So it's kind of an interesting difference. So here's some general topics. Basically, we're going to go through the product and discuss how to use it to find issues, how to do filtering, the common things you do in a protocol analyzer. We'll talk a little bit at the end about experts, the API, and the parsers themselves that I just mentioned. Not probably critical to what you guys do. Well, maybe the experts are, but not maybe writing. But there's just a couple slides on that. And if you guys have any questions, I'm going to go through this probably pretty quickly. Jump out maybe for a demo, too. If you have a question, just raise your hand and we'll answer it. So in the product, you start off with the start page, and it just has some information on the right, recent captures, and then your network adapters. So you can do a capture. There's other places to get to this information, but on the start page, you can select which adapters you want to use when you want to do a capture. And then once you go into a capture tab, there's certain areas of the capture screen you should be familiar with, and if you use the protocol analyzer, they're probably all pretty familiar to you. So we have the display filter on the top. Network conversations is something maybe you haven't seen before. We'll talk about that a bit, but it's a way of arranging your traffic in a tree structure. Then we have the frame summary in the middle, where all the frames show up. So you can click on one, and once you click on one, the bottom section, the frame details and the hex details get populated based on what frame you have selected. So if you're going to do a capture, you'll probably come to this screen. If you haven't selected the adapters on the start screen, you can come here and select which adapters. You can apply a capture filter so that you filter out what you want to see, though you got to be careful about that. And there's some other options under global options. And it's not just the GUI thing. There's not just a user interface for capturing. We also have a tool called nmcap, which is a command line tool, which gives you some other capabilities like scriptability if you want to put it in a batch file or a PowerShell script. It also has things that the UI doesn't have. So on the next screen, I kind of have a table showing you what the UI can do versus what NMCap can do. And probably some of the notable things is in the UI, when we do a capture, it just goes on forever, until you run out of memory, in fact. So it's probably not the tool you want to do if you want to leave a trace running for a day, a week, a month. It's not going to work. In fact, it'll probably get to a point where it gets stuck, and you can't even save the file, so be warned. If you're going to do long-term capture, don't use the UI. It's also not as performant as NMCap. NMCap has certain capabilities to make it run faster. The UI has to keep track of a lot of things, build the conversation tree, so it takes up a lot more, maybe not CPU, but memory, and maintains state for the most part, which uses up a lot of memory. And NMCap does not have to do that. So just some things. If you're going to do a capture, this is some things you need to pay attention to. So first of all, it might seem obvious, but the traffic has to arrive at your machine. And so sometimes I get the question that, all right, well, I'm taking a trace, and I've got a server and a client, and I'm on a third machine, and I don't see the traffic at all. Well, networks are pretty smart, though. They don't send the traffic to every machine on the network. Switches are smart these days. They'll block the traffic. But even if you are on a hub or you are receiving the traffic, you have to put the NIC into promiscuous mode, which is this P mode button on the property. So if you are a third, if you're sniffing as a third party, you want to make sure to have this P mode switch, and that tells the NIC to listen to all traffic, not just traffic directed to it. And then avoid too much capture filtering. The tendency might be to say, okay, I'm just going to capture just SMB or something high layer. And there's lots of state information that's necessary in order to build these frames from the lower layers. In particular, fragmented data is only the first frame has SMB. So if you filter it out in SMB, you won't get any of the fragments. So my recommendation here is if you're going to filter on anything, TCP port is pretty safe to do. IP addresses, Ethernet addresses, of course, are very safe to do. But if you're going to go higher than that, be careful. It's probably just better to filter after the fact. And then when you're capturing, if you're on a busy network, and this might not pertain to you guys, but if you're on a busy network or doing a large traffic on a gig network, a 10 gig network, drop frames are an issue with any protocol analyzer. So you want to pay attention to these fields. The top one's the UI, has a drop frame counter, and in NMCap, it also tells you how many drop frames you have. This is the only indication you're going to be missing frames. You could get a trace from somebody and not realize they're drop frames other than maybe strange things you see in the trace, like missing frames, obviously. But if you don't, if somebody else is taking the trace, they have to pay attention to this to make sure you get a good trace to begin with. And then some things that can cause the drop frames, of course, are high-speed networks, a complex capture filter. So when we filter things, we actually have to evaluate the filter, right? You do something like smb.command equals something. We have to parse all that information. It takes a lot of CPU, and we'll get behind. We actually buffer these frames while we try to keep up with the capture filter. So if we get too far behind, those frames will drop. So you got to be careful with that as well. And then the final thing I brought up here is complex parser profile. So like I said, the parsers are built in, but we have different profiles for different things. So we have a simple profile that's fast. We have a complex profile that parses everything that's potentially slow and might get in a situation where you'll get behind with a filter. And there's blogs on each of these subjects. There's probably a blog. So if you need more information, the blog is a good place to go. So drop frames. So there are some things to mitigate this, and I won't go into too much detail, but we have something called high-performance parser set and high-performance filtering. So if you find yourself in a situation where you can't keep up, these are things to look for, and here is a specific blog that talks about this. I don't think this would be a big issue for you guys since it's usually a controlled environment, but maybe you're testing on a 10 gig network and doing a high-speed transfer or something. We support any of the network monitor capture, also PCAP 2.1 or later. PCAP's a little weird sometimes. There's different versions of PCAP 2.1, unfortunately, but for the most part, I haven't seen many of those. we should be able to open those fine. Most of them fine. So now we're going to go a little bit deeper into the analysis part of the product. So we're going to talk about the conversation tree, because that's a pretty important feature of Network Monitor. Filtering, talk about aliasing, which are friendly names, and reassembly is another important thing that sometimes trips people up. So let's actually open the product rather than looking at a slide. So can everyone see that? I tried to enlarge the font a little bit. So again, we have these different sections, and when you click a frame, again, it highlights in the bottom section the frames you want to see. If you're familiar with Protocol Analyzer, you know that. And then when you click in the details, it highlights the specific details on the right. So you can sort of associate hex details if you think there's some sort of parsing problem or you just want to look at the raw data. But another thing you can do is double-click on this side. So when you double-click on this side, it'll highlight the appropriate section. In this case, it was just the whole UDP section. But here, I've highlighted the source address. So I found something in the hex details I thought was interesting, double-clicked it, and then it highlights it on the left side, on the frame details. Now, one thing you'll notice, and actually I haven't reset this machine, the highlight's very dim. We use the built-in Windows color for that, and it's not the greatest contrast. In fact, in many products it has this problem. You can actually change that if you wanted to, but just keep in mind the highlights there, it might be hard to see. You can also, if for some reason the decoding isn't working, you can highlight a section and do decode as, so you can pick how you want it to decode. I think a common question comes up that, what if I have a lot of traffic, a stream of traffic that's not decoding properly? Currently, we don't have a way in the UI to say decode as the whole stream, but you can edit the parsers, which again are editable. And if you look at the parsers, like for instance, for TCP ports, it's just a big long switch statement with a bunch of case 80 do HTTP. So if you want something else to parse, it's easy enough to add another case statement for another port. And we do hope to improve that moving forward. Also, watch out. So we're going to talk more about reassembly, but watch out for reassembled frames, because we don't do reassembly by default. In Wireshark, it does do some reassembly. So what they do is they take the last message and reassemble it. We don't do that at all unless you press the reassembly button, which is up here. And if you do that, it'll actually run and open a new window, and what it does is it inserts all the original messages in there, plus any fragments that have been put together. I also have a blog on this. So one of the issues is that people, they get confused because it shows up twice. And I could probably find, oops. Well, I have another slide on that, so I'll go into more detail in a second. And then two more things. So say you want to send some information to us at Microsoft. And so what we've done is we've enabled the ability to select some frames, right-click, and copy. And when we copy them, we actually just copy them as text. So if I go in the notepad, I can paste it in there, and their text that has all the data. And you can also do this in other parts. You can do it in the frame details. You can open up all you want to see and copy the entire tree. And so this is useful. Some people like, sending a picture. They'll take a screenshot or something. But if I need to scroll over and see the end of this, it's difficult. So sometimes the text representation is a lot easier to deal with. And also the data in the frame summary is tab separated, which means if you paste it into Excel, it'll do the right thing. It'll put all the things in columns. So if you want to, put the TCP length column or window size and do some analysis in Excel using the table, you can do that. I mean, that's an easy way to export the data. All right, so conversations. Conversations are a way of organizing the data in this tree format. And what we've done is we've built this hierarchy, and you can see that it starts at the top with a process. So if we've done a capture with Network Monitor 3, we save the process information during the capture. You do it in Wireshark, we're not going to have that. But So you can click on, it arranges the data by process at the top, and then below IPv4, so you can see all the IPv4 conversations, below that TCP, and so on. And these are defined by the parsers themselves. So these are, the parser developer decided that, all right, I'm going to make this a conversation. And so if you have your own parsers or you wanted to extend this, you could if you wanted to. But the cool thing is, and we'll go back to the product, is that if I click Outlook, I get all the traffic for Outlook. So it's like a quick way to filter and explore the data. Another cool thing I do with conversations, and I think I have a slide, but I'll just show it now, is that you can quickly explore. So let's say I'm on this side. I see a frame I like, and I say, okay, I want to see, let me find something interesting. So I see this TCP frame. I can right-click and say Find Conversation. So if you use Wireshark, this is similar to Follow the Stream, except what it does is it shows all the conversations. So TCP is Follow the Stream. IPv4 is, I don't know if they have such a thing, but you can find any conversation. And when I do that, it highlights, it automatically finds the TCP conversation in the network conversations tree. It highlights it, and then now you see all the traffic dealing with that TCP stream. So this is a very simple way to associate traffic on the right to specific conversation traffic, like TCP port traffic. And then another interesting thing is once I get to that point, I can quickly kind of go through and, I mean, I could have many of these TCP conversations. I can quickly kind of get a high-level view of how these work. So this gives me a cool, I can arrow down through these and quickly explore this data without having to write different filters for everything. Now, the other thing that isn't as much an issue anymore is in order to do the conversation tree, we have to keep state. The parsers will keep state. And there's different ways to run network monitor. By default, we keep state. We used to not to do that. But with NMCap, if you type a filter that any filter, we're going to assume that you need state. So that part I said where you can run NMCap forever, well, that's fine as long as you don't put a filter on it. As soon as you put a filter on it, it'll assume, because we don't know, we don't have any way to tell if the filter requires state or not, we're going to turn on state. So if you do use a filter with NMCap, you can turn off the state. You can do /disable conversations. And again, there's a blog on this. And you can tell NMCap not to do the conversation tracking, which will save memory. By default, it's on, and you usually don't have to worry about it, but it's just a note that this conversation tracking eats up memory. So any questions on conversations? No?
So
Yeah.
I'll ask you before this one. So your PCAP format is different.
Our capture file format is different. We save in a .cap, which is is based on our legacy format from Netlon 2, 1 or 2x days. We can't save in a PCAP format, but we can save in the cap format. Wireshark can open our PCAP formats. There's some.
You lose all these states.
What's that?
You're going to lose all these states then.
You're going to lose. Well, the state is built by the parser. So the parser looks at the traffic and builds the state. It's not part of the capture format. So every time you load it, we rebuild the state. And the state works with PCAP too. You can see conversations with PCAP files as well. They don't say process information, so you don't see the process tree, but you see everything underneath it. And so I already showed a bunch of these clever tricks. But it's a useful tool. If you get used to using it, it does a lot of cool things. It makes looking at the traffic a lot easier, and surfing through the traffic is a breeze. I just showed you this one, but being able to quickly look at the children for other TCP conversations. It's amazing how fast you can just down arrow and say, all right, that is an HTTP transfer, another HTTP transfer. So it gives you a nice high-level view. One thing I didn't show you is you could right-click, because you can't select multiple things in the tree. You can right-click and copy conversation and add it to your filter. I'm going to talk about filtering in a second, but you guys are probably pretty familiar with that. Also, another feature we don't have is sometimes people want to filter in the conversation tree, like I just want to see Outlook traffic, or I just want to see this port and then build a conversation tree. We don't have any way to do that. But what you could do is build a filter and then just save the displayed frames and open it back up again. So it's a workaround if you ever find you need something like that. So we'll go to filtering. So the first cool thing is that filtering is the same regardless of what you use. So if you use NMCap, display filter, capture filters, they're all the same. You don't have to worry about a different capture filter language versus a display filter language. Color filtering is also the same. You can also do find next. You can say find the next frame that matches a filter. So it kind of gives you another way to explore the traffic based on a filter, and you just go next, next, next. But they're all the same. We have standard filters built in. So on the menu, there's a drop-down, the folder, and then you have a bunch of standard filters. So this helps you learn how to do the filtering if you've never done it before. We have a lot of them built in. You select one, it populates the filter window. We also update the filters. So we have our parsers on CodeFlex. They're an open source. We update them one every 2 months or so. And we also update the filters that come with them. So first of all, make sure you update your parsers. Sometimes we fix bugs. New parsers get updated there. Check it every 1 or 2 months and download the latest ones. And then finally, the last two things are IntelliSense for building filters and Filter Help. And I showed you, you probably saw the IntelliSense. I'll show it again. So when you build a filter, you might not know where to start. So there's a couple of things I'm going to show you. So the first one is IntelliSense. If you hit dot, it gives you the IntelliSense, and you can start exploring. So I can now type protocol, and I'll just type enter, and it did course property. And now I see all the protocols. And IntelliSense keeps on showing you, what you're able to filter on. So it's a simple way to explore the filtering language. Another simple way is you can right-click things. So I can right-click Ethernet type and say add a selected filter, and it automatically just ORs it in. It uses the value that was in the details to build the filter. So now I can find all frames that have this same property or the same value. So all I did was right-click on it. And you can also right-click on columns as well. So I could right-click on the protocol name and add that as a filter. So this is a simple way to build filters based on what you see. If you have an example of it, this is a great way to build a filter. And so these are the things we just went over. Dot starts IntelliSense. So if you don't even know where to start, just hit dot. It'll help you explore things. Color filters is another way to kind of make visual stuff stand out. So you can make TCP retransmit stand out. And in fact, we have a lot of those filters. In fact, TCP retransmits is one of the standard filters that you can see and use. We actually have a bunch of color filters built in, and that's one of them, I believe. Again, those are updated also with the parsers. Right-click add to filters for finding frames that look like this one, and they work in the columns as well. And then the find next feature, which maybe I'll show that real quick. Because I think it's interesting. It's usually not something that oops. So I do Control F. I can type any filter, and I can say, find the next HTTP frame. And there was none in here, of course. Or maybe it was up. Okay, so you get the idea. You can find messages that match a filter. Rather than filtering out, you can go to the next version. So aliases. Aliases is a way of creating friendly names for addresses. So I don't know how many of you, but when I worked, IP addresses were all the same. It was like everything was 192.168.1.1 or 10.10. It was always the same. So this allows you to right-click on an address and assign it a friendly name. So I can do that. create alias for source address, and now I can say this is the server. Oops. And so now it renames it as server. So these friendly names kind of help you diagnose and figure out the traffic. And often what I do when I go through a trace, I'll just start naming things that I understand, like, hey, this is a server, this looks like a client, and all of a sudden the traffic becomes clear because it gives me these friendly names. You can save these alias files. You can have a default alias file. So if on your network it's always the same IP addresses, create a default file and all these names will be loaded for you automatically. Now there's another reason why these names might have friendly names even if you don't create alias files. And so what we do is we look for name resolution traffic. We'll see a DNS request and a response, and we'll say, hey, the response was MSN. Let's use that as our friendly name. And so we'll automatically populate these source and destination with these friendly names if we find them. And it's different than aliases. There's actually two different pieces, what we resolve versus what you name as aliases. Aliasing always takes precedence. So the name, that's the one that's going to be used first. And then resolved, and then whatever the default is. Now, you might have something resolved already, right? It might say, DNS might have resolved the name, and you want to find out what the IP address. You don't want the friendly name. Well, what you can do is add the property back in the UI. So this source column is a special property that says, all right, if there's an alias name, use that. If it's a friendly name, use that next. And then if nothing else, use the raw. Well, if you want only the raw, you can add columns. And you can add any column. So you'll see that we have a huge list of columns. And so I'll just start typing. And this is where it becomes where you might have to know something. So let's say hardware address. I'll just look for. Oh. There. It doesn't really matter. So now I added a column that's always the Ethernet address. If that's what I was interested in, I can add a column for that. You can add a column for anything that we build a property for. Properties are defined in the language itself, the language, the protocol description language, NPL. So that means you could add your own properties if you see fit. If for some reason you wanted to expose something that wasn't a field and add it as a column, or if you wanted to add anything as a column, you could get a property for it if you want to. But we do have a lot of properties built in, like window size. We have a property for it. For most of the common things, we already have properties for it. It's just a matter of finding it. And by the way, if you, in the column chooser, to kind of help a little bit, like all the TCP properties have TCP at the beginning of them, and all the SMB properties have SMB. So it'll be, if you use the name, you'll be able to find them if they exist. Okay, let's talk a little bit more depth about reassembly. So this is an issue that bites a lot of people, and they'll be looking at a message, and what they find is that they look at a RPC message, let's say, and it's not complete. It looks like it ends. And so the typical user is puzzled at that point and can't understand, why can't I see the rest of the data? So what they don't understand is that it's been fragmented. You know, the network layer, TCP, or something underneath has fragmented that data. And we do not reassemble fragments by default, as I mentioned earlier. So to get around this, or to make those reassemble, you have to hit the reassembly button, like I mentioned. It's only available on a saved trace. So if you've done a new capture and hit the reassembly button, I believe it prompts you to save it. I can't actually remember. We have two instances where we save it. But it has to be a saved trace. So make sure that you save it first before running the reassemble. And then it opens a new window and inserts new frames. So I want to show you two things. Well, here's actually a diagram that's better than me looking for a trace. So in this case, you can see that we have an HTTP request, and then underneath it, TCP continuation. So as soon as you see continuation in the screen, that's your key or your clue that you need to do reassembly. Something's been fragmented, and we haven't put it back together. Now you can see that it looks kind of complete. At least there's a header for it, but it's really just parsing as much as it can, and then the rest of it's not going to be complete. So that GIF is going to be cut off. So you'll hit the reassembly button, And then what we do is we insert new frames. In my case, I've created a color filter to highlight these with an underline. So you see that in my case, you have the original frame, the request, the continuation, and then the newly inserted frame that I have my color filter underlying inserted underneath. So don't get confused if you see each frame twice, because all the original data is there, plus the inserted data. Now, I actually have a blog that makes this simpler. There's a filter that says, okay, just show me everything that's reassembled or complete. It's called HTTP frame complete, actually. Suppose I could try to do this.
IP fragmentation reassembly is default.
No reassembly is default. So and that's actually a good point, because if you do this reassembly and there's multiple layers of reassembly, if IP is fragmented, TCP, and then HTTP, we have to put all those fragments together. So first you'll see all the IP fragments put together, and then you'll see all the TCP fragments put together, and then all HTTP. So you see a lot of these inserted underlined messages. Well, if you have the color filter on, the underlined messages. And that's because we have to put each layer together in order to build the upper layer. So nothing's really hidden there. So there's a property called, I think it's HTTP. I don't know why. So complete frame is one, and I think there's multiple properties. But now what it's doing is it's only showing those frames. Well, it should have done that. Well, I'm not going to troubleshoot this right now, but if you do complete frame, it should only show the complete frames. I'm not sure exactly what happened. This is an install I did this morning, so maybe I didn't enable something. All right, so reassembly, make sure you do it. I guess the other point here is that when we reassemble the frame, what we do is we take the original header that's there, because TCP doesn't make any sense anymore, right? It's not a TCP message under there. We put all this stuff together. So what we do is we create this fake frame called payload header. And that's what my color filter does, by the way, is it says, all right, if you have payload header in the filter, then underline it. So it's a simple way of identifying these new frames. Any questions on reassembly? Again, there's blogs on this as well if you need more information. Okay, so frame commenting. So this is a way you can annotate a trace. You put some interesting metadata information to describe something you see, a problem, maybe some interesting traffic. And so what we do is we allow you to add comments. And there's, I'll show this as well. So I can click on a message, and you'll see here in the lower right-hand corner that there's this frame comment section next to hex details. And so I can edit and add a comment. So I say this is a cool frame. I can add some text in here. And what's kind of cool, let's see, this is Windows 8. I wonder if they have WordPad anymore. I don't even know. Yes. So the reason I'm showing you is that these comments are rich text enabled. So I can actually do some rich editing here if I wanted to make stuff stand out. In fact, I could right mouse click, copy the tree. And I could put it in here. Oh, it's all yellow. Great. Make it red. I could highlight something, make it bold. And then I can copy all this and stick it into the comments, and it maintains that formatting. So then next thing you'll wonder is, okay, well, how do I find these comments? I've got some comments in there. How do I locate where they are? Well, in the UI, we have next comment. And what you notice is that next to the frame number, there's a little hash sign which tells you that this frame has a comment in it. And so once you select a frame, the comment information is shown in this window. And so this provides a simple way to annotate these traces. You can save them. Wireshark doesn't open them. It doesn't know about that part of it, but it can open the trace. And you can share it with your friends. Now what's also related here is that we've used this feature to annotate some traces on CodePlex for common scenarios. And so I don't know if I can find it. Probably should have had a link created for this. But I'll just say that there are traces up there that are annotated common scenarios, like for instance a domain join, or there are other ones there. And this allows you to kind of look at a scenario, it'll give you the standard traffic, and you can kind of compare it to yours and kind of understand how it works. And so we've done a couple of these, and it uses this feature to annotate the traces. So that's one use of them, one use of this feature. And the other thing I show up here is that you can also filter on things that have a comment title. So you can also create a filter for all annotated frames. You can also add this comment title as a column in the UI. So you can see that line, in the summary line show up as an annotation, which makes it kind of convenient. If you have a step-by-step what's going on, you can use that column to see each frame. All right, so the parsers themselves, and we won't spend a lot of time, but it's a concise language for describing parsing. It's called the Network Monitor Parsing Language, as you might expect. All the source code for the parsers are shipped with the product. So when you install the product, you get all the parsers. They're all there for you. We update them monthly, like I said. This is the CodePlex address. It's an open source project, so if you had a parser you wanted to contribute to the open source, you could. And you can write your own parsers or customize the ones that are in there. So again, you can add properties, extend conversations if you wanted to. You can specify how the data is reassembled. Reassembly is built into the parser. So if you have a protocol that chops things up, you could write your own reassemble to put them back together. And so I think the most important part of this, or the thing that makes most sense for you guys, is that there's a way to explore the code by clicking. So say you see something, you're like, all right, well, I want to know in MSRPC, I want to know something about this field. And let's say I want to look up the documentation on it. So this is kind of a workaround, I'd say, or at least a way to do it. It's not as clean as it could be. But you can go to the data field definition. And what it does is it plops you into the code. And I should have done data field. I should have done data field definition. And so now it shows me what this, it pops me into the code. You can see that if you want to take a glimpse at the NPL code real quick, it starts off with protocol. Well, actually, it's a structure. So we've created a structure that is this field, but it has all the fields inside. There's a bunch of logic talking about how to reassemble and how to build conversations and expose properties. But what's cool from your perspective is, let's say that you want to go look up some documentation based on this field. So what we've done is at the top of each of these files is we've stated the reference documentation where these are defined. In this case, you can see MSRPCE. So you could go look up on Bing or whatever and do a search, find that document, and then look for that field by the same name, because all of our names, or most of the names in the parsers, match the documentation. So you can quickly go locate that documentation and find out some more information on the field. So it's a quick way to kind of reference the documentation without having to go some manual lookup. It gives you some, at least, starter information. And so all the references are at the top of each of the parsers. So another point about parsers is it's interesting the way they were written. So what we did is we used the documentation. In fact, this is one of our tests, our acid tests inside, to say, is the documentation good? So we said, can we build parsers from the documentation? Don't look at the implementation at all. We'll take the documentations, build some parsers, and then see if we can test how good the documentation is based on that. So one of the interesting outcomes is that if it doesn't parse properly, then what that means, it could mean there's a bug in the parsers, but what it also means is that there could be an issue with the implementation. And in fact, we found some protocol bugs like this where we parse it and, oh, wow, it doesn't look right, but it matches the documentation, so what's got to be wrong? Well, maybe the implementation, or maybe the documentation is wrong. So either way, it gives you a simple way to verify your protocol without having to read the documentation. So this might be your first step, right, is you take a trace, bring it up in Network Monitor, and make sure there's no errors. And one way to find an error, one of the standard ways we actually list the errors, and I actually closed Network Monitor. Why did I do that? Is we actually create a flag, or I create a property called parser error. So I could actually do a filter. And if we in our parsers, we'll check, maybe we didn't parse everything. There's some extra data we didn't parse. We'll flag it as a parser error, and there's none in here, fortunately. This is a simple way. So you run a trace of your implementation, bring in a Network Monitor, look for parser errors. If anything shows up, you might have something that does not meet the documentation. So it's a kind of a simple first check, so you don't have to go figure out if your spec, if your implementation meets what our spec says or what the documentation says. And so when I did this, it brought up the parser tab, and this is just the place where you can rebuild parsers. So if you made a change, this is actually editable. It's a simple editor. It doesn't have many features, but you can make a change, rebuild your parsers, and see what happens. So it's a cool way to experiment with the parsers if you want to do that. There's also an object view on the right that allows you to explore the space, the namespace. So you can go look up by structure or by protocol, by data type. So if you want to look for something, that's another way to find it. And then if you do build something, errors will pop up down here, and you can right-click and go explore the errors. So the whole development process is sort of built in. It's not like Visual Studio or anything. All right, and then finally, the API. So there probably are cases, maybe, when you can use the API to do some testing of your implementation. Maybe you want to run something that runs parser error test on your protocol or something, or you want to, I don't know, look for some data. So included in the product is an API, a library. It's a unmanaged, so it's just a standard C++ implementation. But you can call it for managed code if you want. We actually have a managed wrapper that's distributed with the product. It's not redistributable, so if you create a tool, you can't redistribute the product. It's just it's something we decided to do so that we don't have to manage all those different versions that might be out there. And then all the documentation is in the help file. So if you go help from the menu, the documentation for the API is there. Examples are there. And also on Codeplex, under NM Experts, which is a link you'll see at the end, is where we have some experts that we publish, such as like top users. I was going to show you that, but I realized that I didn't install it on this newer machine. But there's experts built in, so from the menu, and I wish I would have done this. There's an experts menu, so I can say download experts, and what that does is said go to the experts page, which so it brings you to this page automatically. And then here you can explore and download related experts. So NM Decrypt. So this is actually an interesting expert. If you have some encrypted traffic with TLS or SSL, this expert will take that traffic, given the private key. You need the private key, the original trace, and the private key is in the form like a cert. You export it from Cert Manager. And then it'll output another trace with that encrypted traffic. Now, there are limitations. It's not a perfect expert. Sometimes you have to mess with how it works in order to get the correct output, but it does work. There's certain protocol, it can't do TLS 1.2, I think it'll do 1.1 and all the SSL flavors. But it is a useful tool if you have some encrypted traffic and the private key, or if the customer has the private key and they can decrypt it for you and send the resulting trace, that's another option. This is one way to get decrypted traffic. Now, it's only for SSL and TLS traffic. It's not for ESP or other protocols. And then we also have some other experts, top users, top protocols. Some community experts like TCP Analyzer allows you to analyze TCP traffic and get a graph to understand if you have a window size problem or some other issues. So it's a cool tool. And so this is the experts. And once you install an experts, they appear on the menu. The help file is also inline. So if this was opened up, you see the help file and the expert itself. They're independent tools. They're not run within the UI space. So they're just like a separate executable that runs. So these experts don't need to be created with their API. They could be some other tool that takes from the command line the capture file and some other information we expose from the UI. But it doesn't have to be created with our API. But all the ones that we've created, obviously, are done with our API. Can be context sensitive. So what I mean by that is that if you click on a frame, we can, when we launch the executable, we send the frame number that you have selected or the filter that you have applied. So there can be some contextual information sent. And there's a world of possibilities here. There's, if you guys have certain domain-specific tools that you want to distribute to your customers or do checks or something, this is a great way to do it. And so wrapping up, so please install and play with Network Monitor 3.4. It's a free download, don't cost anything. It's on our download center, MS Downloads. You can visit CodePlex for the latest parsers, which includes the latest color filters or any other updates we've done in terms of filters, like standard filters. And then think about experts for domain. If there's something that you think would be useful and you need help, you can contact me via the blog. Or you probably have my email address from Daryl.
So I think yesterday some other session asking question about how to use expert to intercept encrypted traffic, like either Kerberos encryption or HTTPS. To
capture it or to decrypt it? Or
capture is encrypted, then later on, how do I analyze, how to stick these certificates and information into?
Are you saying that you wanted to create an expert to do this all manually, or
So is there for the standard encryptions?
Yeah, so you could create an expert that, I guess, as far as our end and decrypt tool goes, it requires the private certificate and the original capture file. So if you could create an expert to gather that data, there's no reason you couldn't put it all together and make it a simple command line that says decrypt this file. But the problem is that you usually have to go manually find the certificate. I don't know if there's an automated way to do that. Maybe there is a way to export. Seems like maybe with PowerShell or something, you could export the certificate giving you know what it is. You could create an expert that goes through the trace and says, all right, here's the handshake for TLS. Here's the key, the cert key, and go find a match and then export it. So you probably could do a lot of that via an expert. So I think you could.
Currently, UI doesn't have any support to.
All the UI does is say, call this executable, and an executable runs in the background, and then, like for instance, with nmdecrypt, what it does is it calls nmdecrypt. On the command line, it passes the capture file. Actually, it doesn't do that at all. It brings up a UI and says, put in the destination capture file name. Please type the cert password. You hit go, and all it does is it launches Network Monitor with the resulting capture that it creates. So it's not like a total integration, but there's ways to get around it by just simply calling Network Monitor with the resulting trace, and then it would come up again. So there are ways to do that. It's not as integrated as we like. Maybe it'd be nice if we could actually call out and bring stuff in the same instance and do more rich things, but currently we don't do that. Okay. Are there any other questions? Yeah.
Is the packet reassembly reversible, or is it modify your capture file?
So when we, what's that? Oh, yes. So the question was, is the reassembly reversible? What was the other part?
Well, does it modify the capture file?
It doesn't modify the capture file. So when reassembly is done, we actually create a new capture file, and we put all the original data in there. So it's kind of reversible because we never took any of the data out, and then we insert new packets. So you can hit the reassembly button, a new window pops up, and you can say save as and save that file, and then you can pass it on to somebody, and they could say, okay, here's the reassembled data with all the original data, and you'd have both. You could also filter it out and only save the reassembled one if you wanted to pass that along.
And then also on one of your slides, you had some checkboxes in the command line version.
Mm-hmm.
Yeah, there was a checkbox for wireless.
Yes.
And it wasn't checked. Can you explain that?
Okay, yeah. So one of the differences, the question is one of the differences between NCAP and the UI is the support for wireless. And one of the things we do in the UI is we allow you to put some wireless adapters, most of them it seems like today, in a special management mode that lets you scan the wireless, what are they called? The frequencies. So basically what it does is it goes through each channel and scans through them. So this special mode is only available through the UI. It's actually a separate executable. It's not something that is built into our API. There's an NDIS call that you say, all right, put the wireless card in management mode, which then disconnects your wireless connection and puts it in this special mode. And there's another API to send what channel you want to listen to, and there's more information. You can send it. It's actually a separate executable, and you can run this executable on the side, set it up, and then run an MCAP and capture the data if you wanted to do that. It is possible. But it's a separate tool that's only, at least from the UI, it's built in, it's integrated. Okay. Any other questions? Okay. Well, thank you. That's it.